If you're in sports like cricket, baseball, golf, or football, or in army, you might have noticed that sometimes even physically weak players can hit a ball for longer distance than a stronger player. Have you ever thought about the reason of it? Actually, it has something to do with physics. When you are throwing or hitting a ball at any angle from the horizontal, actually you are throwing the ball in two directions at the same time with different velocity. One of them is vertically upwards and the other is horizontal. We can draw a right angle triangle with the hypotenuse having a value of velocity at which the ball was launched, making the same angle with the horizontal as the ball was making at the time of launch. The base of that right angle triangle will represent the horizontal velocity and the perpendicular will represent the vertical velocity. There is no force to counteract the horizontal motion if we neglect the air friction, which we generally do while solving any problem like this, since the gravitational force acting against the vertical motion is way too much than the air friction. Now, to explain it, we can have an example of throwing a ball. Suppose that you have thrown a ball vertically upwards. It will go to a certain height where its velocity will become 0, and then it will come back and will reach your hand with the same velocity at which you launched. And this whole process is going to take some time. Now, to calculate that time, we need to calculate the time taken to complete the first trip of going up and reaching a velocity of 0 meters per second. And the same time will be taken for the return trip. So the total time taken will be 2 times the time taken to complete one trip. And all of this is because of the acceleration caused by the force of gravity. And we know that the acceleration is the rate of change of velocity. So we can calculate the time taken for the ball to reach the height from where it will start coming back with an acceleration with which it was decelerating while going up. That is the acceleration due to gravity. So 2 times of that time is the time taken to go up and come back again. And this is called the time of flight. That is, the time for which the ball stayed in air. The same will be applied for that ball if the ball is thrown at some angle, except for v will be replaced by vertical velocity. So it can also be written like this. Now, we already know that there is no force to counteract the horizontal motion. So the ball will continue its horizontal motion for the time till the ball reaches the ground. And the horizontal distance covered in this time is called the horizontal range. Now, the maximum horizontal range will be for a launch angle of 45 degrees, since the value of sine 2 theta will be unity in this case. At any launching angle other than 45 degrees, the value of sine 2 theta will be less than 1, reducing the value of horizontal range. The maximum height the ball can reach will be the distance that it will cover vertically upwards with the gravitational deceleration to the point where its velocity will become 0. Now let us understand it with an example. Now consider yourself standing as a fielder on a ground. The maximum speed at which you can throw a ball is 30 meters per second. Now let us take the acceleration is 10 meters per second squared. The acceleration due to gravity is 10 meters per second squared is for ease, since it is just an example to explain you in the easiest possible way. Now try throwing the ball at 30 degrees from the horizontal. We can again draw a right angle triangle, and the perpendicular of that right angle triangle will represent the vertical velocity, and the base of that right angle triangle will represent the horizontal velocity. So the time for the ball to reduce its velocity to 0 in vertically upwards direction will be the difference of velocity, that is the final velocity and the initial velocity, to the acceleration due to gravity. The value of acceleration due to gravity is taken as negative, since it is working as deceleration for a vertically upward going object. So the total time taken will be the 2 times the time taken to go up. So we get a value of 3 seconds for the time of flight. So the distance covered in those 3 seconds will be the velocity in horizontal direction times the time of flight. Now you can try throwing a ball at 60 degrees from the horizontal, and in the same way we can calculate the horizontal and vertical velocities. Now you can clearly notice here that the vertical velocity is greater than horizontal velocity in case of 60 degrees, whereas in case of 30 degrees of launching angle, the horizontal velocity was greater than vertical velocity. So in this case also we can calculate the time of flight as done in the previous. So the time of flight is also greater in this case. So we can calculate the horizontal range in this case as we did in previous case. And here we go, we again have the same value of horizontal range. It is because that we have a greater time of flight but a lesser horizontal velocity. Now in our last case of a study, we can throw a ball at an angle of 45 degrees from the horizontal, and then again we can calculate the horizontal and vertical velocity in the same way as we did in previous cases by drawing a right angle triangle. There you go, you have a value of horizontal and vertical velocities that are the same. And again we can calculate the time of flight as we did in previous cases, and then multiplying that time of flight with the horizontal velocity will give us the horizontal range. Now this time we have a value of horizontal range higher than both of the previous cases for the same launching velocity. So if you want to throw a ball for a longer distance without wasting much of your energy, then throw the ball with the same energy but at an angle of 45 degrees from the horizontal. So this part of physics is really important for sports like cricket, football, baseball, golf, etc. and also in case of wars and defense. Just like subscribing to this channel is also really important.